thank you very much. Welcome everybody today to the EVS demonstration, product demonstration. As Justin and I have been talking to many of the investors over the last 6 months, a lot of people have asked us, how does technology work? What does it do? And try to explain a little bit more in depth. So we have taken the opportunity to set this call up today to walk through and give you a small insight into what our technology can do. It's important to note here that our software has a lot of depth to it, and we're not going to have time to be able to go into every aspect of it. And so what we will do is give you a framing of the environment and then the problem statement it's solving, and then walk through that. I'm joined here today by Andrew Barron, our head of products, and Andrew will actually go into quite a bit, so he will have a big talking spot. And I'm also joined by Justin Owen, who you know as our CFO.
Thanks, Jason.
Australian technology, it's very rare that Australian technology like this actually can expand outside of Australia at the scale that we have done. Now with over 400 customers in a host of different geographic and different segments, we are well past that product market fit. We're solving real world and significant issues. But the important part here is we're looking at this always from a lens of how repeatable and how scalable is this. Today, it's about technology, and next week will be about our financial results, which we're really excited to be sharing. We won't take any open questions today. And Justin's got some questions that we've already put in, and we'll be answering them at the end of the call. So today really is around our technology and the capability of the platform. As a bold statement, we've built the world's leading environmental intelligence platform. It's validated by over 400 customers. We recognise that this part of sharing this today is the first part, and we're committed to keep doing this as we grow our organisation out. So today is a snapshot. We will walk through the Omnis, the water, and the aviation product suites. Whilst Andrew is talking through the products, I may interject at different points and give some colour or add certain things on top, but largely speaking, we want to keep this on point. It's important to note as well that innovation is tough. So this doesn't happen just by coincidence. We have a really strong team internally that is dedicated to building out deep scientific and mathematical models, driving an operational and an environmental improvement. So a lot of this, although we're a technology company, it's predicated on us having a really strong team under Andrew in product and our development team. But it also showcases the significant market opportunity that we have got. And what you'll see today is some of the new technology that we've only just added in the last quarter. That gives us confidence there's a significant market opportunity ahead of us. Being product-led means that we want to continue to invest into the product to make sure that we're striving for that innovation and for product differentiation. So what we might do is talk first of all around the company. For those of you who are new to the story, Envirosuite is very much a purpose-driven company. And the statement that you see on your screen now is incredibly important to us. It drives our company, it drives what we do, and it will continue to drive the strategy of where we want to play. But we do believe that environmental intelligence is the key to improving the well-being of people and the planet. So what I will now do is pass over to AB and Andrew. I may call him AB, but AB, you take the reins.
Excellent. Thank you very much, Jason, and welcome everyone to our first ever product overview and demonstration. I'd like to start off by saying I'm incredibly proud for the opportunity to represent the engineers that are currently working with us and have previously, and the scientists that have all dedicated significant amounts of time, effort, and energy and passion into creating the products that I have the pleasure of demonstrating with you today. And they've done this over a number of decades, and like Jason said, the products and their capabilities are incredibly deep and have lots of breadth. So it's going to be difficult to get into each and every little corner, but hopefully by the end of today, you've got a taste for the strength and the usability of the platforms that we provide as part of our solutions. We utilize science, data, and our tremendous amounts of experience alongside technology to help industrial operators and communities carve a path forward together, fostering growth and prosperity for both. Not only do we provide solutions that address both those important constituents, but we focus on some of the world's most important sectors, from aviation, which supports the global economy, semiconductor manufacturing, which is in critical demand globally, through to the resources and minerals that power the world, past, present, and into our future needs. We support important water desalination projects where water is one of the most important resources around the world, through to water purification, waste and landfill management. The platforms that we provide our customers truly are required for them to operate in the rapidly evolving world around them. Today, I'm going to demonstrate products across each of our portfolios: EVS Aviation, EVS Water, and EVS Omnis, giving you a small insight into the products and the tools and how our customers interact with them on a day-to-day basis. It provides customers insight with science-led information that they can depend on to make critical, valuable, and long-term business decisions. I think it's important to note that our systems go far beyond compliance requirements at a site. Yes, it's true that once they're running, they're often bound by operational and licenses to continue to operate, but the solutions really hit the stride with the customers and our stakeholders when they look at how to operate with less wastage and higher profitability and strong ties to the community within those known and emerging constraints, which is exactly where we like to start the conversation with our customers. The platforms come front and center to the daily operation and fabric of our customers' operating plans and community engagement tools. I'm going to start with Omnis, which is a powerful platform that brings together highly advanced meteorological forecasting and weather systems, scientifically based emissions and dispersion modeling, and 24/7 IoT monitoring networks, which gives our customers real-time, predicted, and historical analysis tools to not only ensure their operators run compliant operations, but can actually run as efficiently as possible within those regulatory and social expectations that they have. The things that they constantly face is their need to inform risk and compliance decisions that come up on a regular basis, both short, medium, and long term. They have a continued requirement to support their social responsibility, both to their shareholders and to their staff and local community members. And lastly, through those constraints, find a way to derive and deliver operational growth, which becomes increasingly challenging. But that's where we come in to provide our solutions. These capabilities allow our customers to significantly tighten what we can call their operating window available to them, which means that they can choose when they operate, how much they operate, to ensure that they maximize the tools and assets that they've spent millions of dollars on without creating any disturbances to those key stakeholders and community staff or other environmental concerns around them. Without EVS, using a do-nothing or non-real-time service solutions for either consultants or maybe just a monitoring-only solution, you end up having to use blunt responses to predicted issues, which end up with underutilization or wastage, which I'll talk to a little bit later. The system that is Omnis is varied in its parts, from the IoT network where we collect information from, which includes sensors that we manufacture, through to a very large group of third-party sensors. Means we can capture a significant amount of data into our system. When you put that through our core functionality and our computational systems, which have significant unique intellectual property, it really enables Omnis to deliver critical business decisions. Some of these systems include one called Metrica, an in-house developed meteorological forecasting system that derives accurate forecasts for each individual site in up to 100-meter specific increments. Coalescing that data comes from globally sourced artificially intelligence-based forecasting plans, specific local conditions that we input to the system, such as surrounding land use and terrain elevation. So it's incredibly detailed and specific for the types of operations and decisions our customers are trying to make. Compared with that, we also have our newly launched emissions intelligence system, which uses advanced scientific models to compute, analyze, and monitor the entirety of emissions for a site, predicted emission sources, their rates, where the plumes of those that may be going, 24/7 real-time analysis, historical and predicted information. So these systems directly inform key activities of acting, planning, engaging, and in mining's case, preparing blasting opportunities at a site. With that, I will jump into the Omnis platform. It's 2x. Here we are. Excellent. So
just while Andrew's bringing that up, so this is actually live on our production system. So important part here is this is not pre-recorded; it absolutely is live. So I think it's the best way to show it. So we'll take you through. One of the key parts here is we obviously understand the technology. We will try to communicate this though in a way that our audience today can understand it.
Thanks, Jason. Yep, so what we're looking at is the newly launched EVS Omnis platform, which we released in May and have been continually providing exciting updates to it. So this is the latest and greatest version of the platform. What we're looking at right now is a demo site, which is acting as a mine site for a battery minerals operation, which have ceased operations for a number of years, but with the increased demand for battery minerals, we've seen a number of these facilities open up. While other operations were ceased, we've had communities grow and grow and grow around them. And that's created a really interesting tension between the two and has made these operators, when they initiate their operations again, to work with the community more effectively, to understand what the potential effects are and demonstrate how they can mitigate them, whilst at the same time ensuring profitability to their organization. So we're looking at the monitoring screen, which is showing us the live monitored data, which consists of third-party dust sensors and in-house IoT sensors as well. What we're showing on the screen is the concentration and intensity of dust throughout the facility, which is PM10 in this instance, but there are a vast number of other parameters that we can bring up and display at the same time. We bring to the fore the real-time weather so that the operator can make split-second decisions as to what's occurring. What we're seeing down here is that we have a couple sensors that this afternoon are both red and orange. Companies can set them up depending on what operational decisions they want to make. So red may not necessarily mean that they have an exceedance. What it could mean is that they need to do something about it very quickly. And when you're looking at this and you need to determine what you need to do very quickly, often the answer doesn't lie at the sensor, but it lies somewhere else on the site. And so what this is showing is a large arc of influence, which takes into consideration using Metrica and emissions intelligence systems, where that likely dust is coming from and what volume it's coming at. So if I need to make an operational decision to adjust this number, I want to be looking inside this area and this arc of influence. I can quickly see what the trend is over the last 24 hours to see if things are trending up or down and where it may relate to my potential exceedances and decide there. And very easily, I can drill in instantaneously and see what each 10-minute segment has led up to in the recent past. If I look to the other side, that's what I would currently be doing. Modeling is one of our most advanced capabilities, which enables organizations to use our predictive technology to look into the future, taking all of their site parameters, their types of emissions, and their concerns into account to determine what operating plan they may want to enact to ensure that they remain compliant, but don't necessarily have to cease operations, which is an incredibly powerful tool for them to be able to deploy. So what we're looking at is the modeling screen. And what I'm going to do is tomorrow morning at 7 a.m., I want to determine what the day looks like for my teams. So I'm going to model from 7 a.m. to 24 hours in advance. And what we're going to do is initiate a model which will look for the forecasted dust concentrations using all of our emissions intelligence capability and Metrica through that time frame. And what you can see as I move away is the size, length, and density of that plume. And you can see the site is surrounded by a number of virtual sensors. If these are triggered, they can alert the teams to that they likely have a situation that they need to respond to, and they can then decide whether they want to increase or decrease their activity in that given time period. This creates an incredibly powerful capability, especially if you know that you're operationally able to work when there's a northwesterly wind. So in this case, we have no problems. But if you look at other time frames, you're potentially looking at a potential risk, and you want to then tailor your operations very specifically around that. Another thing that occurs is we've planned as best we could. However, potentially we have someone that's complained of a potential issue in the last couple of days. Now, in a traditional sense, it could take days, weeks, or hours of individuals' time to figure out what we were doing that day, how much dust there was, where it may have come from, to respond to that community complaint. And with the rise of the effectiveness of social media and community groups to get together, if you can't respond to that very quickly, you quickly lose control of the conversation. What Envirosuite allows you to do with its historical information is run things called a trajectory. And with the trajectory, you can create a situation whereby you say, I want to look at the time and date of the complaint, which was 8:40 yesterday evening. And I can bring it up, and we'll use all that advanced meteorology and emissions intelligence to carve a direct path of where the emission started, T-minus 60 minutes, to where the complainant was. And if we look at where our facility is, we're actually well off here to the left-hand side. So we can take this, knowing that it's scientifically back to the community member and say, we appreciate your concern. We've done some scientific analysis on it, and this is what we think's happened. This both covers the duration and the shape of the emission, but also shows you its likely elevation through that entire time period, even allowing you to drill in to the particular heights and densities of that particular over that time. So you get a really powerful response very quickly.
Just want to jump in on that one. So whilst this might be for dust in this situation, all of the other environmental parameters can be modelled in a similar way.
That's a really good point, Jason. Thanks for pointing that out. On the monitoring screen, on this particular instance, due to the site type, we're talking about dust and PM10, but we can run the entire program over a variety of other inputs, including dust or odor, which is one of the other key use cases for this. And you apply many of the same processes to an odor operation as you would a resources sample like this. Another very powerful capability of this platform is something called Source ID. So you potentially want to understand what your prior activities emissions have created. You can't always put a dust management sensor or an odor sensor in the middle of your site. It's just not practical. You can't get to it, it'd get driven over, a whole bunch of other tactical things. But then the question is, how do I work out how much dust has come from this area in the past? It's actually quite a difficult computational challenge. But again, with the platform, you can make a very quick analysis of that. So I'm going to run back to Sunday at 9 p.m. and the algorithms will have run over that data. And what I can see here is that this area was orange and this area was green. I can quickly open it and I can assess through synthetic calculations using emissions intelligence just how much emission we believe was generated from that area, which can then significantly assist in making future operational plans to ensure that you work within known constraints of your system. One last thing I'll jump onto. It's not on this particular demo site, so I'm going to have to move around a little bit. But our recently launched noise capability, which takes a significant intellectual property that we have in our world-leading noise monitoring terminals and through our aviation organization, and brings it right to all of the users in Omnis. So this is another demo site which focuses on an odor facility, and it's got a number of odor detecting monitors throughout it. Again, a combination of Envirosuite and third-party sensors. I can then run in and look at decibels in the same interface. So we now have a monitoring terminal. I'm going to go back to real time for a second. And what I'm able to do is, on the same interface as all of that, is understand all of the advanced noise monitoring capabilities we have. So you can manage your 5-minute average, 15-minute average, hourly average, daily averages, maximums, all in the exact same interface. And for some of our heavy industrial customers, this simplifies their operational environment significantly. Excellent. So that's my overview of Omnis. All right. The next one we're going to touch on is our EVS Water portfolio. Largely, the EVS Water portfolio is focused on utilization of digital twins of our customers' facilities, combined with scientifically based deterministic modeling and machine learning capabilities to utilize the easiest sets of inputs available to derive the most advanced sets of output, helping them perform more effectively and reduce their risk. There are three main products in the EVS Water portfolio. We have SUEX, which I'm going to discuss in a little bit more depth and to do a demo of. And there's Plant Designer and Plant Optimizer. Plant Designer is a planning design tool, of which Optimizer is the bigger brother, and which I'll discuss shortly. Today we'll be demoing SUEX, and we'll leave Plant Optimizer for another day when we have a little bit more time on our side to do a demo of. Plant Optimizer is a very unique and comprehensive tool for our customers who are very much based in using traditional-based methods to understand how they can optimize their operations. They are constantly juggling with power bills, chemical dosing choices to achieve either drinking water requirements for an area or industrial return of water to local communities. Traditionally, this has been via what we've always done for the last 5 to 10 years, which both has a lot of risk and can incorporate lots of run-on costs. So what we do is we create a digital twin of their facility. We use deterministic modeling using 70 different scientific processes and layer that machine learning on top of it, and essentially provide them hour-by-hour set points for the next 24 hours of operation, which tells them how much temperature to use at a certain area, how much chemical to dispense at a certain area. In some of our most recent site examples, upon the initial recommendations derived over 20% reduction in their chemical usage. In just one email, it said, this is what you did yesterday, this is what you can do tomorrow, and we show them a 20% benefit in those things. So it's an incredibly powerful platform for them to gain access to. And that works for both water purification and desalination facilities through to light and heavy industries and food and beverage type industries as well. All struggle with the same constraints and are looking for the same answers. Swapping over to SUEX. SUEX is an incredibly powerful platform that gives sewer operators never before access to timely and in-depth insights as to how the network is actually operating. It's only ever been previously achievable through manual labor and high volumes of testing and validation, which actually just hasn't been possible on a regular basis, and it's not really helpful for understanding all of the different parameters across the entire network. What SUEX does is it takes a modest set of measures and inputs and uses machine learning to derive an accurate simulation of that network. Immediately, that simulation provides detailed cross-network data of the system, where the raw biomass might exist, where the buildup of methane gas is going to be, where hydrogen sulfide is. And all those different scientific and chemical-based parameters play a really significant part in their operations, whether it be the increasing demand for them to understand what their impact on climate change is with methane emissions, through to safety with hydrogen sulfide. And one that we've likely all experienced with the smell, the unpleasant smell of hydrogen sulfide being emitted in your neighborhood. Not being across these things means that the community experiences the odors. You have to then respond with a very short time frame and not much information. We give you that information, not just today, but an ability to predict it going forward. The magic of SUEX is actually when customers start to ideate and test potential improvements to the networks themselves. Investing in a new chemical dosing station or ventilation program can be a capital works program in the tens of millions of dollars. Not something you want to do overnight because you've had a reported or unexpected issue, but something you want to plan. You want to plan very effectively. So SUEX, we're using SUEX, the customers can independently build and test these changes to their networks, not in days, not in months or weeks, but in hours, which used to be a task that was led up to potential consultant engagements that they had done 1, 2, or 3 years previously that they continue to rehash. This puts the tools in their hands and demonstrably makes a marked improvement on their processes and their ability to plan into the future. So we're helping them with climate change, with their safety, their odor, and the corrosion. The system that goes behind SUEX, again, I stress that it takes in a modest number of inputs, which means our customers can get up and going really quickly. We take in their hydraulic model that shows where their sewer pipes are going, how large they are, and a number of sporadic samples through their site, which are generally very easily collected or already known. With that, we build that into the model, and even soon releases of SUEX will allow them to build the model themselves. And they'll be able to then run our model process on as many different iterations of their potential systems that they want. And that will tell them where they have hydrogen sulfide buildups, where corrosion is happening quickly. And if they do such capital investments, that this will be the derived benefit for them. So they'll get more accurate representation of that risk in their capital allocation and more efficient and effective responses to their complaints.
Just on that, so when you talk about those inputs, I think it's important to state that that is data-driven inputs that we're taking from the customer.
They're data-driven inputs. Typically, they're difficult to get across your network. Some of these samples you need to collect en masse when you're doing a manual approach and put the samples on ice and take them back to the laboratory and get information from. Not something you want to be doing every week. You can put 1 or 2 of those samples throughout your network in SUEX, and we will work out the rest. So we're really giving them a solution that is not otherwise feasible or achievable to do. Now, jumping into the SUEX product, Aquaroma is another demo site that we have running in our production environment. And what you see here is the customer's sewer network, which outlines all of their pipes. It has their sizes, it has their flow rates in them, which they all typically have on hand and provide into this and upload it to the system. We then have all of the different manholes throughout the facility, gravity mains, wastewater treatment plants, pumping stations are all built into this network. What you then do is they create a scenario, and we essentially have a vanilla scenario here, which has calculated throughout their entire network all of these different parameters. So without measuring or sending people to site on a daily basis, we've simulated what the likely minimum, maximum, and mean biomass, which is the raw sewage, is at this point in time across their entire network. And what you can do, it's not just single time, it's time phased. As humans, we have diurnal cycles, which means there are different behaviors through a sewer network, morning, day, and night. And they significantly influence what those min maxes are and what your response may be. So we model these throughout the entire data set, which is often 24 hours. It's not in this particular demo case, but it will traditionally show a 24-hour area. So this is raw biomass simulated throughout the entire facility. The next thing we can look at is hydrogen sulfide gas. So again, without measuring physically in situ, we've been able to calculate with their input files where and to what level of concentration there's hydrogen sulfide gas. This is measurable in traditional setups, but hydrogen sulfide meters don't stand up very well to the incredibly harsh environment that is a sewer network. They're expensive and they're hard to maintain. So the ability to simulate all of these things is incredibly powerful. The things that influence the level of hydrogen sulfide are factors such as flow time and speed, anaerobic, how much air is present in the system at the time, if there's a rising main nearby to increase the flow, and the concentration of dissolved oxygen. If there's none of that available, bacteria use the sulfur and generate hydrogen sulfide. And what the SUEX model is doing is running all of those models and predicting them into the future so you can work off a real simulation of what your system is potentially going to look like. Now, if we're looking at a potential hydrogen sulfide issue in this node on the system, you may want to do something about it in a future planning cycle. However, when you attend site, one of the other things that operators are very conscious of is the amount of methane gas. Traditionally a safety issue, and if you arrive and the issue is much more significant than you planned, it poses a health issue or safety issue to your workers and can often stop and have work pre-planned. However, as one of the other models that we run through the system, we also predict methane gas amounts. So I can flick the system over and you can see the maximum methane gas concentrations across the network. Generally, anything over 5% to 17% is known as dangerous, if not explosive. So what we can see is in the area of work we would potentially be initiating, there is a higher level, but it's not nearly 1%, so we can probably initiate that work. So this information is helpful not just for the operations team who may need to be responding to it, but what we've seen is once the sewage operators get a hold of this, other departments start to hear about the types of information that they can glean from the simulation, and they want to start getting involved in the system so they can start making their decisions. So it's really powerful that way. The other exceptional power to this is not just simulating what your system looks like today, but it's simulating what could potentially happen and what the benefits and changes to your system are if you make changes to it. So one of the key changes that a sewage operator could make is they could add a dosing station, which is a fixed facility that essentially deploys chemicals into the sewer network that either increases the amount of oxygen, that's ventilation, or helps the chemical breakdown increase flow and improve the network parameters. Now, considering the number of inputs required to make that determination as to its impact, there's actually quite a lot of computation that goes on. And that's where SUEX comes in, because you can, as an independent operator of these things, without external help, including ours, you can say, I want to run a new scenario with a new testing concept of a dosing station. So what you can do, I'm just going to turn off the skipped nodes that we don't use, and say in this gravity main, I'm going to add a doser, a theoretical doser. So we'll call this GM23 dosing concept. And it will dose at 75 milligrams per liter, and the doser will be active. So I'll add that to the system. And I can then say scenario, add scenario. I can input all the different potential data inputs that I have, whether I have new water quality parameters or new velocity or flow information. And if I don't, that's okay. I have my GM23 dosing concept, and I've also got a trial 3407 dosing station, which is actually outputting more 100 milligrams. I can then create that scenario, and it will derive an entirely different simulation demonstrating those downstream impacts of it. So again, a really powerful tool once you get all the different departments that are interested in augmenting the network to achieve their different departmental goals.
So just to re-emphasize this point, so this is totally unique software. This is, a strong IP that we now have. How would our customers go through this process previously?
So previously, what they would have to do is predetermine years potentially in advance all of the different options that they want to run. It then gets taken to an expert, generally in a consulting capacity, who would use historically the SUEX model in a once-off derivative with each of those different simulations in it, taking into account no changes over that period of time. Give you a printout or an Excel sheet to say, here are all the different changes. And what we see is that customers will refer to that, not just when they receive that study, but for 1 year, 2 years, 3 years, to make their capital planning decisions based off of that. This way, They can self-serve all of that information, ideation themselves, and come up with a really effective capital planning tool. I like to see that this is one of the best examples, I think, of democratizing some of the world's best science. We're taking what used to be a very difficult to use and utilize piece of technology and building a really significant wrapper around it so they can take advantage of it. Thanks. All right, so that is us and SUEX completed.
So last one now is aviation.
Now is aviation. Excellent. So aviation is one of the most significant portfolios for us globally, as we are the far and wide leader in the field. It provides our customers the ability to operate. It's demonstrated significant resilience through the impact of the COVID situation that was placed on aviation for the last 12 years, and they literally can't fly without it. Our tools extend significantly beyond just noise management. It's a comprehensive environmental management solution. It's depended on by 150 and more of the world's largest airport hubs. They are each multi-billion-dollar assets that are themselves looking for stability and growth opportunities. So they have to manage the regulatory framework to ensure their assets maintain their value, but also grow. So if you have the opportunity and the desire to, say, add a new runway to your airport, which is an incredibly important growth opportunity for the airport, and you're not able to demonstrate how you may do that within the realms of the community pressure and the noise constraints that you have, you may be disallowed. And that there are a number of situations around the world where that's happened, and airports have not been allowed to expand. The same thing can happen to operating curfews. You have a midnight curfew that gets imposed on you, and you lose 6 hours of potential inbound or outbound flight, which again degrades the value of that multi-billion-dollar asset for almost its lifetime. So having a system like AEON's, which they can depend on, is backed by scientific information, and works well across all different departments and community members, is incredibly important to them. The challenges that face an airport that we help with are far and wide. This goes far beyond measuring noise at a single place in time. We do that, but we also correlate it with a significant amount of aircraft flight data, aircraft data that helps them work through procedure compliance. So we help them manage their departure and arrival corridors. We help them when they need airspace redesign through those corridors and making sure that they comply with or effectively change potentially the noise map that they have when they move that airspace. They're also looking for optimization. We compute airplane tracks, not just in the air, but on the ground. So we can look for bottlenecks in the air as well as bottlenecks on the ground to help them utilize their asset more effectively. They're also significantly impacted by reputational loss. If that community starts to gain momentum and build a strong case against them, that can again have detrimental impacts to their operation. A long emerging but significant one of late is global warming as well. As stage 1, 2, and 3 emission controls start to come normalized around the world, the airport is a large contributor in that, not just in what happens on the ground, but all of the airlines that enjoy using that airport start to impact that facility's global warming footprint. And so the AEON's product helps across all of these different capacities, taking in a significant amount of information. That information extends from noise monitoring terminals, flight tracking in the air and on the ground, noise correlation, flight path, corridor, and curfew infringement management, through to understanding carbon usage, and providing all that through transparently to communities through engagement portals and the like, which we share the real-time data through to them in a consumable and navigable format, which has become very important in some of the world's most contemporary airports to work with their communities in a proactive fashion as opposed to a passive fashion. And in many of those interactions, the information that Envirosuite provides them is front and center to those discussions. We consolidate huge amounts of this data. The multiple airport stakeholders that utilize it demand that we know and capture all of these things. In the last 12 months, we captured over 40 million flights, calculated and correlated them with millions of noise events, corridors, and operational infringements, which literally allows them to operate, manage their airport effectively and compliantly, both with their communities and with their tenants and airlines and the like that use those systems. Along with the core ANOMS platform, we sell a distributed set of noise monitoring terminals around that facility in the numbers of 5, 10, 15, 20 of these absolute world-leading noise monitoring devices, which integrate deeply to the ANOMS platform. They make at-the-edge calculations as well as interact with the platform to correlate noise with flight traffic and the like. Customers use the suite to engage with the communities on existing operations, planned expansions, and verify and improve ongoing compliance. That's done with extended modules that are both community-facing and provide near real-time historical engagement and flight traffic and noise data. I'm going to jump into the demo, whereby I'll walk through 2, maybe 3 different aspects of it. I'm going to start with a product called WebTrack, which is the community-facing portal at a number of our airports around the world. And then I'll finish on ANOMS X, which is generally used by the airport to manage their facility.
Great. They're going on the water.
It tastes fantastic.
Good, right, Joe.
Thank you. So for today's demo, I'm going to be using the London Heathrow region as a demo facility. And this is available, by the way, if you are interested as well, in Melbourne and Sydney. If you just look up WebTrack, Envirosuite, Sydney or Melbourne, you can see the same type of information. All of this is calculated through the Envirosuite platform and presented through to the community on behalf of the airport. Most airports that have the WebTrack solution, when you drill through their corporate website, say, I have noise questions about your airport, send them here. Say, if you want to understand what's happening, this is a great first place to start. And so what you can see here is near real time, all of the different flight traffic. Now it's nearly midnight or so in London, so there's not a whole lot happening. But all these yellow dots through the facility are the Envirosuite noise monitoring terminals that are constantly recording. Not sure if you're going to be able to see it. You may have to, I can't zoom in much closer, but you can see the 64 and 68 are the number of decibels being recorded at that particular noise monitoring terminal. You can see this one's going up, 78, 81. That's because that aircraft is flying across it. And what you can do is actually see real time what the impact of that aircraft was over your flight. And doing this increases the amount of trust that an airport has with its surrounding community because they can check themselves. You can also click on a particular flight. You can make a direct inquiry about it to the airport, which will come through to the ANOMS system, which we'll jump into a second. So you can report the aircraft. You can see what its track was, or you can show how close it came to your home, which is really interesting. And part of this personalization is what really helps the airports engage with their customers. So in this case, I can say, I'm going to locate my house on the map. So if I live down here in Horton, never been there, but I hear great things. I can then click on a operation and say, show me what the point of closest approach was. So this tells me that the closest approach time to my house was at 6:13 in the morning. And it came within 3,200 feet of my house at 15 degrees. And you can see the real-time change of how that's traveling. Now I can do this now, or if I was having a barbecue yesterday and somebody had questions about all those planes that were flying over it, I can do that as well. I can say historical. I want to go back to my barbecue on Sunday and load this entire interface for that period of time. Takes a little bit to load. We're not actually going to wait for that. So this is one of the tools of actually a number that the airports deploy using ANOMS-based data to demonstrate the activities that are happening at their airport. Excellent. So now what I've just logged into is a product that we call Omnis X, which is a very user-friendly platform designed for all types of employees and staff at an airport to engage with the significant amounts of information that we collect, to help them make operational decisions, to engage with airlines, and to make planning decisions and engage with the community on their complaints. So what we're seeing, I'm going to actually skip back just to yesterday, because it gives me a little bit richer data for what I want to talk about. What we're looking at are all of the flight traffic and movement that we recorded across the London Heathrow region. There are actually 4 or 5 different airports in this area. Just yesterday, in this subset of data, we collected 2,500 different flights that landed in this area. I can also bring up all of the overflights and any other uncharacterized information. So the amount of information you have access to about every plane that traveled through that airspace is significant. So there are 2,500 flights here. I can monitor all different aspects of it. So we have correlations here which show up. Let me see if I can correlate it. This is showing that I have curfew issues that have occurred within those operations. I have noise events that have happened within that time frame. I can zoom in a little bit more here and I can say, let's talk about events that have had a continuous descent or continuous takeoff infringement. This is a new standard that was brought in a number of years ago to help reduce the amount of noise and the amount of carbon that's emitted for planes during descent and takeoff. If you've been on a flight, maybe not too recently, where you've noticed that during takeoff, you hear and feel a big push of thrust as you stabilize, that actually uses a lot more carbon than if you just drift slowly and accurately down to the ground. So specifically in Europe, they're asking all flights that come into certain airports to practice those behaviors. And our system manages all of those different behaviors and helps them track down the amount and who's potentially breaching those things. So I'm going to try and bring up a specific flight here, which I believe had a continuous descent infringement on it. I can bring that up, and what we show is its actual descent through the air, and where we've picked up that the pilot chose not to continuously descend for that period of time. I can see the entire operation, and I can open it and look at more detail if I wanted to. I can see the weather, and I can see the details around those rules, and I can put some comments in here at the same time. I can also hit play on that particular flight, and we can watch that plane traverse through all of the other air traffic as it happened on the day, and potentially gain some insight as to why the pilot may not have chosen to follow those continuous descent infringements. I can also export these, where it creates a pre-forma letter that the airport can then send through to the pilot or to the airline themselves to answer a please explain type activity.
Can I just jump in on that point? So I think it's an important part as well for people on the call. In this particular area, we design and manufacture our own high-end microphones. So those noise monitoring terminals are going in. So part of the secret sauce that we're providing here is not just rich, complex calculations on our servers and in cloud. It is actually around also collecting the data from the actual airport and the community around.
That's right. Another great example of that infringement type thing that I think is also very natural for us to understand is a corridor infringement. So different times of day, different winds, the airport's required to enact different corridors that the airplanes must stay within when they're acting. So this particular flight, BA 352, flying from Heathrow to Nice, lucky them, actually had a corridor infringement on this particular event. So you can see the corridor that was enacted during its flight. What you can actually do if you want to understand exactly what happened is you can interrogate the specifics of the flight, and you can see the exact corridor and 3D space that it was supposed to stay in, and we can see that very clearly it exited the airspace at that point in time. all based on the systems and information that we collect and correlate and manage through the specific track data and track rebuilding that we do, understanding what flight it is, what plane it was, where it was going, all those types of things. The last one I'm going to touch on is in regards to a noise infringement, which was flight 006, which was London to Dubai on this particular occasion. So I can click on it. And what it does is it gives me, there are 2 flights at this point. And what this is doing is showing the connectivity between our noise monitoring terminal, which is determined that there's an issue. It's told the ANOMS platform to start an investigation. It's then looked for what potential traffic was in flight at that point in time in that location, and it is connected the specific time and place of that plane in the air and the amount of noise that's coming out. And you probably can't hear it, but we can hear an aircraft on this side creating this noise all the way up to the red peak. You can download, save it, and correlate it through. When you think about how much power is in this system now, it's immense. The number of flights that went through that day and the specificity of which you can see exactly what noise complaints happened, when they happened, what it sounded like, what the operational conditions was, what the weather was, what the surrounding traffic was. It really gives airports an insight as to that aspect of it and allows them to remain compliant. The last area I'm going to touch on is an area, I think, Justin, you mentioned in our recent update around carbon emissions and its take-up. It uses all of that calculative information that we have on flight tracks and whether they're doing continuous descent operations, how long they're taxiing for, how long they're circulating the airport for, and builds a viewpoint of how much carbon is actually being used by flight, by airline, and all those types of things, which allows the airport, almost like doing your tax return. What we used to do was approximate how much carbon we think we created based on standards. What we now do is take that from standards to empirical data based on all that information and tell you exactly how much was used for what type of operation. So I'm going to jump in here. I'm just going to pick some better dates for this. So what this is doing is just for the London region. It's showing you the amount of carbon gas that was emitted for all the traffic that we measured.
So this is the cumulative.
This is the cumulative daily or monthly aggregated amount of carbon that gets used. We have approximately 4.5 gigagrams, which is 10 to the power of 6 kilograms amount of carbon that was created during that period, with over almost 300 million passengers on those flights and 1.8 million movements. Jason, your favorite question?
What do we think happened to predicate that significant drop?
Yeah.
So if there was a microphone open on the floor,
bottle of wine on offer,
there was a significant event that happened to the airline industry.
That's right. Now, the macro sides of this are really interesting, but what you can then start to dig down and do is say, let's see what type of aircraft created those individual impacts. So we can see here that the cumulative took over. So there was a change in mix of aircraft in that late period. Prior to that, we were seeing Boeing 777s, 777s, A320s as significant creators to that. You can then break it down between domestic and international if you want to compare the two. And we won't go into it, but we can also see different airlines' behavior. So you can say different airlines with different airplane configurations through different phases of their flights, how much carbon was used, and empirically create data and information from it. So that is the summation of my presentation or my demos today. Just from where I started off, I just wanted to say I'm incredibly proud to be able to stand in front of this technology today and share it with you and give you a taste about what our platforms and the significant amounts of technology underneath them are capable of providing. The insights that give us customers are truly the platforms that they need to operate into the future. So hope you took something away from it. We're really excited for where this is going. We have a very exciting roadmap for all of these platforms over the next 12 months. And I'm sure this isn't the first time you're going to get a look into our products and platforms.
Very good.
So with that, and back to the panel.
To a couple of questions.
Okay, thanks, Andrew. That's fantastic. So we took the opportunity of giving those who wanted to or wish to attend today the opportunity to deal with some questions. So in the time available, appreciate it's pretty tight, but we'll just run through. So the first one I've got here is, in any bid or tender, what are the reasons a customer chooses Envirosuite over a competitor? And second part to it, what is your win rate?
All right, so I guess there's a couple of different things, but I think what Andrew has demonstrated today across all three product suites is the depth and accuracy on what we can do from real-time monitoring and from the predictive capability. When we go in against others, it is clear, very clear early on, that our accuracy is important to customers. And for them to be able to drive an operational improvement, they need to be able to trust the data. And so I would suggest that is the strongest part. But then secondly, I would add to that the breadth of where we are installed around the world and for some of the logos. We proudly look after some of the largest industrial customers and airports around the world. And that tenure of engagement and the business model that we've created, I think, is very clear on that part. Answering the win rate, the hit rate on that, once we qualify a customer to say, do you just need a simple dashboard versus do you need operational decision making, we actually have a hit rate now above 60% across the board. And so we're very strong once we're able to qualify that out. So our segment is not for the low end of the market. Our segment is for the industrial customers. This is not about greenwashing. This is about doing something real.
I think additionally to that, what we end up seeing is companies, when they see the depth of decisions that they can make from it, they quickly want to look beyond the compliance conversation and say, oh, if you can show us that, how else can we derive value from your platform? And then the conversation changes completely. Yeah.
Okay. Thank you. Moving on to the next one. So Envirosuite's platform connects to its own devices, but is it also able to connect to third-party devices? How easy is it for these third-party devices to integrate to Envirosuite's platform? And is this done via an API or some other integration method? A couple of bits to unpack there.
I'll go first, and then Ava, you jump in. So look, we have designed our business model here around three different product strategies, right? So aviation, we connect to our own noise monitoring terminals. We can also connect to third party. We like a vertically integrated business model because we believe we can get a richer source of data, which just adds more meaning to our customers. In Omnis, we are absolutely agnostic we can connect to any type of device within reason, IoT device. The only question there is accuracy of data. So that there is a term, rubbish data in, rubbish information out. We want to make sure that it has certainly got a quality to it.
And I think where there were gaps in the market for available IoT sensors to help our customers solve the problems, that's where we stepped in. But by and large, we see a significant third-party network of devices that support our product.
Yeah, and certainly that from a supply chain and building resilience into our customers, we want to have global supply agreements to do that and to build that out. But we're also, we're always looking for world-leading technology to partner with.
And for water?
Yeah, so water is no sensors, right? So water is a data set, and so it is a pure SaaS play, highly scalable, and we can turn it on incredibly quickly.
And sometimes there are sensors, but they're very much common within our customers' installed systems.
Already in place. Yeah, that's right. Yeah. Well, actually, there's a question there on APIs, I think, which we should pick up.
Oh, yes.
So I think APIs is an interesting part, right? Because we know what we do, but being able to provide APIs to our customers or to other data sources that are existing, you can then get a richer or a different data set to build in. So not only do we have active APIs today, but it's certainly an area that we would want to continue to go down that path. And there's a host of different applications, say within mining, that you can see there is a rich data set available.
Okay. Now, conscious of time, we'll go for one more question.
I think so.
Last one. Last one. In an enterprise sale, who is Envirosuite's main sales stakeholder? Is it compliance, strategy, or IT?
I love the it depends question, but it's an it depends one. So look, I think that if you look at it at a macro level, somebody has to have a problem to solve. And so it starts with that entry point, right? You need to identify what is the problem that we're trying to solve for them. But what we want to be able to do within enterprise is move that up into an executive sponsor, right? To understand how does this drive their business. And it's an important part, right? We come back to this every time. It's environment, it's community, it's industry, right? We want to drive that engagement piece. And so those stakeholders, then they can actually see the benefit. As you said, right, this is more than just compliance, right? This is really driving transformational change. And so we see that executive sponsor. You know, we often recite back to, Water Corp or Tech Resources as a customer, but in all of those, there is that executive sponsor that says, Envirosuite's coming in, it's mandated, it's helping us from, regulatory requirements, it's helping us from a business planning perspective. And
no, it does. One of the interesting things we've seen specifically with water is they have very active digitization strategies to help them modernize how they manage their network. And when they see what we do, we fit right within those strategies. And they're all over the conversation and excited about what we offer in that space. I think you nailed it with the Omnis one. It can traditionally be compliance, but it can also be operations. And once they hear about it, you generally get both in the same way.
And that's when it pushes up into the true enterprise type sale, as opposed to a solution to a problem that someone has immediately.
Exactly.
That's it, Jason, for questions and time. I'll hand back to you to close out for the day.
No, thank you, and thank you for everyone joining. I noted at one point there we had 100 participants, so I think it was very well attended. Really appreciate everyone's time. As we said at the start, this is the first one that we have done. We do want to actively engage with our shareholders to share the exciting journey and share the opportunity. I think what you saw here today is incredibly advanced technology. As an Australian, I'm incredibly proud that this technology has been built in Australia. I'm incredibly proud of the engineering students who have got the masters and the PhDs that are inside this organisation who are driving forward this company to bigger and better things. So even though we've had a fantastic 12 months, I feel we are scratching the surface of what we can do. And I think the product today clearly demonstrates that. So thank you. Thank you for attending. If you have got any questions as well that you're intrigued on, please forward it through and we certainly will come back. Anything else, guys?
No, it's great. Thanks everyone. Looking forward to spending more time with you on the product.
And for me, look forward to seeing many of you next week when we release our financial results for FY22.
Thank you.
Thanks very much.